good morning or maybe good afternoon. You know, this plumbing engineering is really a challenge course for everybody. So I hope that as I go further and explain to you what I have archived, which is different from even the International Plumbing Code, Uniform Plumbing Code, can help a lot for us master plumbers, plumbing designers, to approach the true design by using their data imparted to us. Seems to say that we need it as a true designer, and we can produce our image recognized internationally. Okay? So, the permissible loading of horizontal drain and soil stock for a tall building will be the one that prevails on this lecture for this condition. Thank you very much. So I hope that this can add knowledge to what you have done. This topic, you cannot find it in our revised National Plumbing Code because we don't have any data on this. I was lucky that I opened an archive of the United States Planning Manual that shows the relationship of the horizontal drain and the soil stock for a tall building. Even in the plumbing code of the US, we used to have the Uniform Plumbing Code. We used to have the International Plumbing Code. Did not reveal the true design procedure on the permissible loading of the horizontal drain and soil stock for a tall building. Now in our case, I have to show you the much difference of what we have known about plumbing system in the horizontal and the vertical relationships of the drain, waste, and vent. This one is the most important in our designing. I will show to you the anatomy of the building in our plumbing system. This one, the soil stock, the vent stock, and the horizontal drain. As we have known that all horizontal drain will just discharge to the soil stock, but not the case in a tall building. There is always a permissible. It seems that you have to have permit, allowable loading. It is not discharging only without knowing. We know the capacity. Yes, the capacity of the pipe. But to discharge with the horizontal drain, there is always an allowable. It says that the pipe say, don't discharge too much because I will be overloaded. So this is the case on this soil stock and the horizontal drain. There is always a relationship. I thought plumbing is an art, but as I read the manuscripts of Dr. Roy Hunters and some other professors of the Iowa State University, there's a lot of mathematics, higher mathematics in a higher order, like differential equations in a higher order. We know algebra, geometry, differential calculus, integral calculus, differential equations, and higher differential equations. In our case, we have more mathematics in electrical engineering. As I read the manuscripts, our system, we ourselves as a master plumber, we are just in a bird's eye view. But we do not know the worm view. The worm view is that there are more mathematics involved and the experimentations that Dr. Hunter had derived, and equations, fixtures unit, and everything. Relationship of interference between horizontal branch and the soil stack itself. I used to give this hydraulics formula for money. I don't have to elaborate further because in most of my hydraulic drain waste and vent lecture, this is the same equation that we are studying also. We have a full bore and we have a half bore. But in the plumbing engineering, most likely the most efficient is the half bore. Because when there are surges, it will not just overflow the pit trap or the trap seal that we will have, but it will just rise because this one is empty and only this water is half filled of the pipe. So the half full flow or half bore, it is equal to the area of flow of water divided by the perimeter, weighted perimeter of water. So this one is the hydraulic radius, which is the half area of the circle divided by half perimeter, which is d over 4. Full flow is the same d over 4. Half full flow or half bore, the same d over 4. So you know, Manning roughness coefficient, you can have Manning roughness coefficient 0.12 for PVC, 0.15 for cast. I will give to you the derived formula which you will be using in your computations. The Manning equation is this one. How do you find the diameter from this equation when there is no diameter involved here? But it is embedded in the area of flow and the hydraulic radius. And the area of flow, it depends if it is half full flow or half bore, or a full flow which is full bore. So we will rearrange this one into the other side, and what is remaining, the white one of the equation, is in the right side. So the same coefficient, this coefficient, Manning, the normal slope that we will have is 1/4 inch full per foot, which is equals 2.08%. That is the normal. So if we solve this one equal to this equation, it yields 0.449 cures the power 0.37, or this 0.449 raised the power 0.375 is equals to 0.74 cures the power 0.75. This is now the diameter in half bore or half full flow that we will have. So the diameter in feet, Q is in cubic feet per second, half bore. The same also, the diameter at full flow, we rearrange the area here and the hydraulic radius on the left side, and in the right side is the white, which is the Q, N divided by 1.486 times the square root of the slope. So, the same, 8.15 cast iron. So, diameter, this one is the full flow, pi d squared over 4, and the hydraulic radius d over 4 is the power total. Qn 1 divided by 1.48 over S, over the square root of S, I mean. So, you process these equations and diameter will yield equal to 0.569 joules per 0.38. That is full bore full. Then feet, cubic feet per second, N is 0.015, S is 2.0. So, this equation, you can already compute how much or what is the Q. If you want to compute for the Q, just use this equation. Diameter divided by 0.15 and then the square root of the root of 0.375. So that is your Q. So these are now the derived equation that we will have in determining diameter. The 2% slope, 0.686 joules to the power 38. 38 is 0.375. Is 38. For concrete or CI pipe, 2% slope, 1/4 fall per foot, D equals 0.74 joules to the power 3. D in feet, Q. So this one is derived from the original Manning equation. Example, for horizontal drain or branch interval by using Manning's formula. I will show to you how to size from this example taken from the engineered plumbing design by Alfred Steele, Dr. Alfred Steele. The upper zone upper stack has 4 intervals, 4 branches. The lower stack has 1, 2, 3, 4, 5 branch intervals. Okay. This discharges to the stack. This horizontal branch discharges to the stack, and then the offset is the same formula. We are using it here also. The same formula we will be using for the horizontal branch of A, B, C, D, E, F, G, H, I. All the red ones are being computed as the horizontal branch. The same slope, 1/4 fall per foot. Okay. I encircle this one because there are relationships of this vertical and horizontal. The relationship is that could I permit you to discharge her? That I will not be overloading? So that is the relationship. So this one, if we use a certain diameter of pipe, we will investigate if it is safe to discharge this fixtures unit. The same thing in here, it will because what is being discharged in the upper zone that we will have through the offset, it will goes down also to this lower zone. So it adds up the load of the lower zone. So it means to say this has a bigger diameter than this stack of the upper portion. So we know this is all the red one are being computed. I show you already the fixtures unit because this is the total of all the fixtures unit we'll have for the building drain. I computed it already as 8 inches diameter. We make a schedule of loads. A schedule of loads in every level of the horizontal branch. As I said before, our schedule loading for electrical is almost the same as the schedule loading for the plumbing system. The plumbing system has an appliance load. The electrical also has loading in terms of watts or kilowatt or volt ampere. Here we have our loading in terms of fixtures unit. Our computations on this type is half bore. It is always be half bore. Because full bore, when there are surges, you cannot have leeway for the pipe diameter that it will not backflow. So we introduce manning here because Dr. Roy Hunter uses the Archie equation. The Archie equation doesn't have the hydraulic radius, but Manning has hydraulic radius. Our tabulations here for level A, B, C, D, E, F, G, H, I. Our tabulation for A, the same as the example. We have 70, 90, 120, 90, 150, 180, 160, 190, 200 drain fixtures unit, in which the total of the feeder is 1,200 drain fixtures unit. Okay. We have an equivalent because we cannot just solve the diameter just having a fixtures unit. But you have to see the equivalent of fixtures unit from the Dr. Roy Hunter's curve. So, like the 70 drain fixtures unit, if it is plus tank predominantly, it is 35. It is plus valve predominantly, it's 58 gallons per minute. But in Manning's, we use English system, the feet and the cubic feet per second. So, at the cubic feet per second, it is plus down. The 35 is 0.078 and the 58 is 0.125. It means to say, this one and this one are the same. This one and this one are the same. So, all the levels, only that it is cubic feet per second or cubic feet per second, we are using this level. This column, we are using all this column, the plus bar. It's greater volume of flow, the plus bar. This is the schedule of plumbing loads in terms of fixtures. You have heard the appliance loading. We have the water closet, bidet, lavatory, shower, urinal, bar sink, kitchen sink, laundry tub, bathtub, floor drain, goods washer, and others. You have a drain fixtures in equivalent. You can use that. There is also here an equivalent to our revised national plumbing code. What is a water closet for private, bidet, and the other. So how many quantities that you will have in each of that, and then the total drain fixtures unit. So by the use of Manning, the same D equals to 0.74 Q is the power 0.75. At D equals 70, the demand GPM is 35 cubic foot per second, 0.078. Substitute the Manning formula equals to 3.41 inches diameter or 4 inches diameter. That is by the use of planning. Now, sometimes you can say that that area is predominantly plus tank. So you use the equivalence for plus tank. If it is predominantly plus bulbs, you use the equivalent of plus bulbs. So you have to have a schedule of plumbing loads. So the total DFU for a level B is 90. So whatever is the quantity here, you put the quantity. So the drain diameter and the trap diameter. So 90 equivalent to 3.6 inches diameter or 4 inches diameter. So you solve some other in the tabulated table. So you solve an equivalent schedule of plumbing loads. So the last is in level I, you have 200. 200. So should it be, the diameter there is 4.3. Should it be 4 inches or 5 inches? But we don't have 5 inches. You may say 6 inches. So anyway, that is only a conduit of flow of water. It is not the basis of a permissible values. This formula here that we are using, we got the diameter of 0.375, 0.358 feet or 4.3 inches diameter. This one you multiply by 12. So if I say half bore, you may use 5 inches. If I say full bore, maybe you have to retain 4 inches. So that is how you consider what size of conduit that you will have. Let's go back to our sizing example. This one, this horizontal drain that we will have is already solved. If I did not show it in the board, you solve it for whatever it is, the equivalent of the diameter. Okay? So, how about the this offset? Okay. What is the diameter of the offset? I say there 6 inches. Okay, but I will show you the solution. How about this building drains? I say it is 8 inches, but I will show you the solution. How do you size the offset or stack runoff drain? Offset has 370, and the demand GPM is 98 for plus tank. I use plus tank here, 0.218 cubic feet per second. The diameter is equivalent to 5 inches or 0.418 feet. For 5 inches diameter, 6 inches diameter. That is the offset of stack run out of the higher level of stacks. The offset for the building drain, which is 1,250 drain fixtures unit, I use plus tank. Our demand GPM is 239, 0.532 cubic feet per second. Applying formulas, we can say that diameter is 0.584 feet or 7 inches. Since we don't have 7 inches, say 8 inches diameter. So we have now the building drain. We have now the offset from the higher slack, higher zone, which is 6 inches, and we have 8 inches. Although 5 inches is okay if we have, but we don't have. In other countries, there are 5 inches, say 8 inches. But in our case, there is no 5 inches, say 6 inches. These are the equivalent fixtures unit. The slope here is 1/4 inch fall per foot. And these are the equivalent full bore. This is computed full bore. Darcy-Weisbach equation or Darcy equation. For 4 inches, 216. Full bore. But there is no allowance. That is full bore. There is no allowance. So 6 inches is 640 fixtures unit. It says that the building drain. I got the definition from the government of the US from plumbing manual that the building drain or house drain is the part of the lowest horizontal piping of a building drainage system which receives the discharge from soil, waste, and other drainage pipes inside the walls of the building and conveys it to the building house shower beginning 5 feet outside the inner face of the of the building wall. This is from the plumbing manual uh, of the US uh, Bureau of Material Standard. Now, we have here 4 inches, 4 inches, 4 inches. And we have here 6 inches, 6 inches, 6 inches. And we have here 6 inches. And we discharge the 370 to the K and L. And the letter J, we don't know how much is the letter J that we will have and how much diameter of L that we will have. The L is the stack and the J is the stack. We have to know the relationship between the branch and the stack. So, okay. So since you know this already, we have solved it already. So let's proceed. This is what I would ask. What are the sizes of stacks? Stack J and stack L. What is the relationship between the stack and the horizontal branch? What is the permissible fixtures discharge of the branch to the stack? So we have to determine the soil stack capacities. This equation of Q is equals to 27.8 R raised to the power 5 over 3. D raised to the power 8 over 3. This equation will give you the real GPM of the stack. You see the stack, there is an annular form of annular. This is the water. This is actually the water. At the center of the stack is the core of air that flows down below the stack. I see this is a phenomenon. Because there is a form of an annular hair that the equivalent values for this blue one compared to the area of the pipe, the design used is 0.29 or 29% only. It means to say, this one is only 29%, the blue one is 29% only. That is water. The 70% hollow here is the core of air. So that is 7 over 24, which is 29%. This equation, we can find the diameter 0.6 to take Q as power 3. Q is in GPM now, D is in inches. And what is the terminal velocity? The terminal velocity is 3 times Q over D raised to the power 250. This terminal velocity is the one that this annular drops to a certain velocity, which is in relation to Q over D raised to the power 250. And the drop here is normally from 15 to 18 feet per second. That's why in my previous example, in my lecture, that even at 100-story building, it will not fall down directly as a free fall. It manages to slow down because it will create frictions between the water and the pipe itself. So the terminal velocity is somewhat like 15 to 18 feet per second. So, and the terminal length, it drops somewhat like 15 feet that forms this annular, that is a terminal length, that is equal to 0.52 the velocity, terminal velocity squared. So, this we have to know. No? We have to compute this one. For example, what is the stack capacity of 4 inches pipe? From the equation, Q is equals to 27.8 R raised to the power 5 times D raised to the power 8 over 3. Our stack capacity is 724 raised to the power 5 3 times 4 raised to the power 8 by 3 is 144 GPM. From Hunter's curve, 144 GPM is 530 fixtures unit. The same thing for 6 inches pipe. We substitute values from this equation. We have 424 GPM and we have 2,900 fixtures unit. For 8 inches pipe, we have 913 GPM. Q here is 913 GPM, which is equivalent to 7,600 fixtures unit. If you want to make computation, it's easy. But if you want tables, you can have. This table is from the NBA stock capacities of the diameter of the pipe. Like for example, the 4 inches at 0.29, this is 0.29 is 7/24. We have 144 fixture, discharge GPM of 144 GPM. This 144 GPM is from this equation. And the 144 GPM is the equivalent fixtures unit from the Roy-Hunter's curve, which is equal to 530 fixtures unit. So for 6 inches, 0.29, that is the ratio between the sheet of water and the area of the pipe. So 0.29 is the desired design capacity of a pipe. Don't design more than 0.29. Maybe you allow 0.3, but more than that is not anymore acceptable. So 5 inches, 0.29, we have 1,400 fixtures unit. That is equivalent GPM that we will have to 61. The 6 inches, 0.29, 424, equivalent to 2,900. The 8 inches, the 10 inches, the 12 inches, and some more, which is, you cannot see here, we have 15 inches. Okay, so this one is, we can use, because the limit of our vertical stack, or our soil stack, is these are the limits, this one. These are the limits of our stack. That our stack should not be more than, for 4 inches, 530. Some other code uses only 500. The 5 inches, the 6 inches, some other code uses 1,900, which is not within this soil stack capacities by National Bureau of Standards, BOS, United States. This is the demand GPM by Dr. Roy Hunter's curve, where a GPM there, or GPM plus bulbs, are equivalent to the fixtures unit loading. These are the fixtures unit loading. You will just find the GPM to the fixtures unit loading. It is plus tank or plus bulb. You can find it, the fixtures unit. What is the permissible load of the horizontal branch to the stack? Yan ang tanong. Ang akala natin, we have to discharge all fixtures unit in the horizontal branch to the stack without knowing anything there. But it is much different when you speak of a tall building. This one is the stack. This one is the flow of water. This one is the annular. When this is overloaded, maybe the air core here is only 20%. This will not flow. This will not flow. But it will flow back. May backflow. So, the backflow now will rise the water to the pit trap or to the trap cell. And then, when this already goes down, the water already goes down, it will siphon all the trap cell from the pit trap. So, these representations of interferencing of loss in stock fittings. Kailangan natin ito. Kailangan natin ng mga principles na ganito. Sapagkat hindi pala ang lahat madi-discharge yan. Lalo na kung meron siyang laman na dito. Meron ng laman. Okay. Pag may laman na ito, itong annular na ito, itong annular na yan, ang cross-section yan, ito ay hangin. Ito ay, itong blue ay tubig. Pagdating dito sa intersection na yan, pinipigilan niya itong flow. Pigil. May backflow and will overflow trap cell or siphon the water cell. Because this one has the capacity to hold the water. Why? Umiikot ito eh. Ito ay umiikot. May centrifugal force ito. Pag-ikot niyan, ang ibang tubig dito, talagang itatapon niya dyan sa loob. Kasi umiikot ito. Kaya kailangan, hindi ganitong na yung sanitary T ang gamitin mo, kundi yung long-term T's or Y are used for the connection of the branch to the stock. The discharge has the greater vertical ballistic components as it enters the stock and back pressure are appreciated this for the same stock and branch flows. Ito ang kailangan natin malalaman ng principles na ito. Hindi ko nalalaman ito kung hindi ko na-archive itong mga manuscripts ng paggawa nito, mga experiment ng paggawa nito. So, ito phenomenal ito. Phenomenal yan. Okay. Ang relasyon ng horizontal pipe and then the vertical pipe stock. Ang relasyon ay nasa experiment ni Dr. Ray Hunters. Hindi lang ito experiment. Maraming mathematics itong involved dito. The theories and principles involved. Akala ko it's an art. No, hindi. Akala ko it's only an experiment. No, hindi. There are plenty of mathematics involved there. Higher mathematics. So when you talk of worm view, parang nasa loob ng pipe si Dr. Ray Hunter. But we ourselves are given already the table na parang you just pick it up and eat it. But you want to test it right, you go to the kitchen and see what is the recipe there, what are the ingredients involved. This is what Dr. Hunter's doing. To know what is the ingredients involved, to know what is the principles inside. Ito ang ginawa ni Dr. Hunters. Okay, ang experiment niya, kagaya nitong 3 inches diameter, ito ang chord. Ang chord na ito, nagbigay ng relasyon ng flow of horizontal branch in GPM at saka flow in stock in GPM. See, for example, you have the flow and capacity of stock. Ito ang ang intersection, ang relasyon doon sa sinabi ni Dr. Hunters, Q2 is equals to 40% only of Q1. This is Q1 and this is Q2. 40% only of that. Of this Q1 is equals to Q2. This is the experiment of Dr. Hunters. That's why there are limits. There are permissible. It permits only that flow. Kung hindi ka, kung sumubra ka sa flow na yan, forget it. You size another size of stock that you will have. You resize it. Okay. I'll give you the example. Permissible loading of branch stock for 4-inch diameter pipe stock. Dr. Hunter uses 0.3 instead of 0.29, 0.3 ang nagamit niya. maximum stock GPM capacity is 151. From Dr. Roy Hunter's experiment, the ratio of permissible horizontal discharge to stock is 40%. From Hunter's chart for core for EQ versus GPM, 60.4 is equal to 80 fixed years unit. 80 fixed years unit, that is 1 or 2 branch interval. At table A7, permissible stock load is 240. Okay, itong 80 fixed years unit, ito yan. Ang 1 branch interval, so interval between horizontal branch and horizontal branch, that is 1 or 2. 1 branch interval or 2. We use is 2 here. So 80 times 80 plus 80 plus 80, this is now the capacity of the stock, which is equal to 240 fixed years unit. So, this is 1 branch interval, this is 1 branch interval, 2 branch interval, sinasabi niya, 80, 80, 80, that is 3 times 80, 240 fixed years unit. I will show you the table. Load limits for horizontal branches, single interval stock. The pipe diameter is here. The horizontal branch capacity is here. Load limits of the horizontal branch. And single interval stock. Load limits of the stock. Okay. HCCL4 is 160. Where did this 160 came from? Kanina, sinasabi natin, 40% of the maximum GPM is 151. That is 60.4. 80 for 1 interval or 2 branches. 2 times 2 times 80 is equals to 160. That is any time i-discharge mo yung 160, okay, any time i-discharge, sabay. That is the maximum you can have 160 fixed years unit in that branch. So 6 inches stock capacity is 424 GPM times 0.4, 169.6 GPM. So, which is equals to 310 fixed years unit. For 2 branch is 620. Dito ang 620 na ito. Dito nanggaling yan. So, you see the table, ha? You see the table? May table na tayo na binigay sa US National Bureau of Standards. Pero iba ang table na ginawa ng International Plumbing Code at saka yung Uniform Plumbing Code. Wala. Hindi maintindihan. So, ito ngayon, ito equivalent nito, the same processes that we will have. Ang 8 inches, 1,400, and 10 inches, 2,500, and 12 inches, 3,900. Ang 15 inches is 7,000. Ang maximum, so for a single interval stock or 2 interval stock, sinabi dito, parehas lang naman ito, is 510, 930, 2,100, 3,760, 5,850. So saan ang galing itong 930? 6 inches stock, 620 divided by 2, 310, times itong stock na ito. Itong isa nito, ang capacity nito, kung 6 inches itong stock nito, kung 6 inches, ang horizontal branch niyan, equivalent niyan, is 310. Ito 310. Ang capacity nito, 3 times 310, which is equal to 930. So, the same for ang 8 inches. Ang capacity nito, isa nito, ang solusyon ito rin. 1,400 divided by 2. Ito, 1,400 divided by 2. Itong isang discharge na yan. Kasi dobleng horizontal ang discharge. So, 2,100. Ito ngayon ang equivalent ng maximum permissible loading. You will be using sa design natin. So, table A7. Kanina A6, A7 ito. The same also. the permissible fixtures unit per branch interval has an equation. Okay. This equation is n multiplied by 1 over 2n plus 1/4. That is the permissible fixtures unit for branch interval. So, nililimit yan into how many intervals and how many horizontal, and the maximum of that stack capacity. So N is permissible load on stack 1 or 2 branch interval. N is number of branch interval. So, kanina, the same ito 240, 540, 930, 2,900. Ito kasi magagamit natin ito sa design. Ang load limit naman, kanina, yung Q is equals to 27.8, R is the power 2/3, D is the power 8 over 3. Ang ito, ang 530, ito ang load limit niya. Ito ang load limit ng stock natin. Na ang 530, hanggang dyan ka lang ang D4 mo. Ang 5 mo hanggang dyan ka lang sa 1,400. Ang size mo is hanggang dyan sa 2,900. Okay. Let us investigate. This one is from Dr. Alfred Steele, engineered plumbing design. Okay. The same also as in the International Plumbing Code. Parehas lang ito. Parehas lang yung data nito. Yung D4 kanina, sabi na, stock 3 stories or less. Ibig sabihin hanggang 3 stories, hanggang 3 stories lang o 2 story o 1 story lang, 1 floor. The maximum loading is 240. 240 fixtures unit. Stock more than 3 stories. Ibig sabihin, mga 4 story na yan. The limit of the maximum loading here is 500 only. 500. So, the maximum stock fixtures unit is 500. Yung kanina, pero sa itong IPC, International Plumbing Code, is 1,100. Yung sa original is 1,400. Ang sa IPC, ito, 1,900. Ang original is 2,900. Ito ay 3,600. Ang original is 7,600. Di divert data. Pinaliit nila. Bakit? Hanggang saan ba ito? Okay, kagaya nito. Ang discharge capacity of one branch interval, isang branch na yan, isang branch, is 90 fixtures unit lang. Ibig sabihin yan, ang 500 divided by 90, 5.5 floors lang o story. Diyan lang sila sa 5 story. Hanggang dyan lang sila sa 5 story. Kaya nito, ang 200 nito, ang sinasabi na, isang branch interval, isang branch niya, horizontal branch natin, hindi ka dapat sumubra sa 2,000, sa 200. So, 1,100 divided by 200, 5 story pa rin. So, ibig sabihin na, ang capacity niyan, kay 1,100, hanggang 5 story ka lang. Ang 6 inches, okay, 1,900 divided by 350, 5 story ka pa rin. Medyo hindi tama yata. Because wala lang multi-story building. Hindi mo mailagay dito na tama siya. Tingnan mo na ang ano dito, 5,600 divided by 1,000. 5 story pa rin. Lahat may 5 story ang height ng building. dito sa data nila. Okay. Ang International Plumbing Code, halos parehas sila. Okay, ito kinopya. Okay, sa table 6, correct na nan. Lahat, correct. Itong 90, for floor or branch or higher, puro 90 lang sila lahat. 4 story. Ito ang stock 3 branch intervals or less. Ang maximum sa stock is 240, correct. Itong sa 5 inches, 540, correct. Ang stock capacity limit nito, fixtures unit, greater than 3 branch interval, 500. Ito is stock capacity, ibig sabihin niyan. Correct ito, 500. Pero ito ngayon, 1,100. Ang tunay nun is 1,400. Bakit? Ang limit nitong 5 inches is 1,400. Ang limit ng 6 inches is 2,900. I will show you back. I will show you back. Tingnan mo. Ang 4 inches is 530. Ginawa nilang 500. Okay lang yan. Maybe may discrepancy lang sa chord. Ang 5 inches, 1,400. Kung i-compute mo ito, galing dito, ito yan. Galing dito. Ang fixtures unit is 1,400. Ang 6 inches, compute mo galing dito is 2,900. Ang 8 inches, compute mo galing dito is 7,000 fixtures unit. Ang 10 inches, 15,000. Ang 12 inches, 26,000. Galing dito yan. That is the load limit. Okay, that is the load limit. Okay, balikan natin. Dito tayo nagkatalo. Itong 160, sa IPC, 360, 620, 1,400, correct lahat yan, pinupyan nila. Pero itong 240, 510, 930, 21, 3760, at saka 58, 10,000, ito government, yung ano nila ng ni Dr. Roy Hunters at saka yung sa Iowa State University yan, Iowa University. So, ito, instead na 540, ginawa ng 500, ito ginawang magkano ba yan? So, ibig sabihin yan, hindi pantay at saka hindi parehas yung ano natin. Oh, ito, kagaya nito, sinabi ko. Ito. Ito ang galing sa plumbing manual natin sa government of the US, 540. Ito, 930, ginawa 960 to 100, ginawang 22, 3750, ginawang 38, 5850, ginawang 6,000. So, medyo malapit, di ba? Malapit. Pero hindi tama eh. Ito ngayon ang permissible stock limit. Ito ngayon ang capacity ng D4. Itong capacity ng D5. Itong capacity ng size. So, ang capacity ng size, kasi stock limit ito, more than 3 stories. Hanggang saan ba? 5 story lang ba? O kung 8 story? O kung 10 story? So, ang limit lang nito is this one. This is derived. This is derived. This is derived. Yung kanina sinasabi ko how to derive it, nan-derive na yan. Ito ay galing dito sa Q is equals to 27.8, R is the power 2/3, D is the power 3, 8 over 3. Ito nanggaling ito. Nanggaling na ito sa ano, ang ano is 0.29 ang ratio of the sheet of water to the area of the pipe diameter. So, ito, galing ito, the same also sa IPC, International Plumbing Code. Yung kanina, 160, 360, 620, parehas yan. Correct yan. Pero itong branch interval natin, hanggang every branch, 90 sila. 90 na. Wala lang, hindi nila masasabi na hanggang 84 ba, 85 ba, o magkano ba, kung 6 story yan, o magkano bang kailangan mo. So, 200, sunod sa 5, 350, Ito ang 205, 350, 600, 1,000. Ito, ang 1,000 niya, 1,405 ang actual yan. Ito ay capacity ng pipe. Ito capacity. Ito ngayon ang inaalaw na capacity ng pipe sa 3 branch interval or less. Ito ngayon ang basihan ng computation natin. Ito ngayon ang limit na more than ilang story. Ito ang limit. Ito ngayon ang capacity ng pipe. Okay. So maximum load, ito table A6, table A6, table A6. So what quantity should we limit the flow of the horizontal branch? Okay. The fixture's unit capacity allowed for the horizontal branch will interfered by the flow of the sewer stock for multi-story building. Reference table 6.3, maximum permissible load for sewer stock. And table A7, ito US government. National government. A, maximum load within any one branch interval. B is the maximum load on stock. Okay. What is the maximum load within any one branch interval? We have a formula. The horizontal branch fixtures unit is N times quantity 1/2N plus 1/4. N is the permissible load on a stock. Permissible, it is allowed only for 1 or 2 branch intervals at the table E7. N is the number, small letter N, number of horizontal branch in the branch interval. B is the total fixtures unit of the stock. Ito ang kung paano natin ma-limit yan. Kung paano natin ma-limit at sa paano natin makukuha. Example, sinabi nila na 90 fixtures unit ang kailangan ng D4. Hanggang dyan, karang. Kung hindi na sinabi kung ilang story yan, ilang floor yan, sinabi lang na 90. Okay. What is the limit of flow in the fixtures unit of horizontal branch to 4-inch diameter pipe installed for a 4-story horizontal branch? So, from table 60 or 7, permissible load of branch to enter into the stock is N times 1/2N plus 1/4, where N is equals to 40, N is number of branch. Maximum load of the branch is 40 times quantity 1/2 times 4 branches, which is equal to 90 fixtures unit. So the stock load for 4 inches is 500 fixtures unit, or 530 to be exact. So how much is the loading here? Is 360 only, because 90 times 4 is equals to 360. That is how we load the horizontal branches. That is how we load the horizontal branches. Okay. Example again, the 4 inches. We will make it as a 6-story horizontal branch. 1, 2, 3, 4, 5. Or 5 story. 5 or 6. 1, 2, 3, 4. 1, 2, 3, 4, 5. May 6 pang-anim dyan. Pang-anim. Palagay na may 6 tayo dito. Okay. So, maximum load, the same to 40. Maximum load is 1/2 times 6. 6 is 80. Fixtures unit. So may isa pa dito na 80, pang-anim niyan, ang total niyan, 80 times 6 is 480 fixtures unit. So stock load, the same is 500 fixtures unit sa D4. So ito ngayon ang mga branches yan ng mga building natin. Kung building mo ngayon is 4-story, ganun ang sistema natin. Ganun ang ano niyan. So, hindi yung nililimit mo lang siya hanggang 5 lang. Nilimit siya hanggang 15 o hanggang 50. 50 story. Nililimit mo siya hanggang dyan. Okay, back to the example. Okay. Okay, this one. Ito ngayon ang kailangan natin. Magkano ba ito? Ang kanina, ang 4 branches, 90. Ang 70, pasok. Ang 90, pasok. Ang 120, hindi pasok. Sa 4 inches, ha, 4 inches. Ang 90, pasok. So, hindi ito pasok dito, hindi permissible ito na pumasok sa dito, itong 120. Anong gagawin natin? Ha? Anong gagawin natin? Ang sinasuggest ni Dr. Alfred Steele, ganito. Referring to table 6.3, that is, for a 4-inch stock of more than 3 stories height, the maximum loading permitted is 500 pictures unit. Although the maximum loading of 4 inches branch is 160. Per table 6.4, this load is limited by table 6.3, which permits only 90. Sinasabi niya 90. To be introduced into 4-inch stock, in any one branch interval, the stock would have to be increased in size to accommodate branch load exceeding 90. Kailangan mo pala i-increase. Kailangan pala i-increase. So when we go back as a pattern, itong 1, 2, 3, 4, 90 siya. Dito, 120 nakalagay dito. Ito 70 nakalagay dito. Ito 19 nakalagay dito. Ito 90. Ibig sabihin, pasok sa only the 120, hindi pasok. So kailangan ang 4 inches stock, gagawin mo 5 inches. Okay. Okay. Horizontal drain limit to sewer stock. What is the limit flow of the fixtures unit of the horizontal branch? 5 inches. Okay. Gagawin natin model ito. Ha? To upper stock. Ang fixtures unit for branch permissible load for branch to enter into the stock is and the same formula. May formula tayo. 540. So you substitute it 4 inches here, the 540. The 5 inches ito 5 inches. Is 202 fixtures units, say 202. So, 200. 202, 202, 202, 202, 800, 800. So, sobra na ito, 120 lang dito, 90 lang dito, 70 lang dito, 90 din dito. Okay, itong 5 inches. Stock load is 1,400. 808 lang. Okay, but do we have 5 inches diameter pipe? You resolve to 6 inches. Okay. Ganito yan ang mag-load ka ng ng stock natin. Hindi basta i-discharge mo siya, i-discharge mo siya, i-discharge mo siya. Baka mabulunan at saka ma-overload. Okay. So, ang 5 inches, ito na yung maging model natin. Ang pangalawang model natin, yung baba. Ang baba na loading natin ay ang level E, F, G, H, I. 150 fixtures unit. 180 fixtures unit. 190 fixtures unit. 190 fixtures unit. 200 fixtures unit. Ang capacity ngayon ng 5 inches na yan is only 190 for 1, 2, 3, 4, 5 branches. Capacity is 190. So 200 dito, 190. Hindi rin pwede. Kailangan mo the size pa rin. You move to another size instead of 500. Okay naman sana ito. 1,320. 1,320. Ang total nito is 1,250 lang. So, okay na. Yun ang ano natin. Okay. Another example. Model to upper stock. Bakit? Yung 6 inches natin, okay naman ang 5 inches, di ba? Kaya lang, ang 5 inches natin, wala tayong 5 inches. 6 inches ang nangyayari dito. So, ang 6 inches natin is 350 fixtures unit per horizontal capacity. So, ang total niyan is 1,400. Stock limit is 2,900. So, lahat nito pasok sa 6 inches. 6 inches. Ang itaas, 6 inches dahil walang 5 inches. Okay man sana 5 inches. Kaya lang walang 5 inches, 6 inches. Okay. What is the limit of flow of the 6-inch stock installed? Okay, dito naman tayo model to lower stock tayo. Meron kang pumapasok na 370 fixtures unit. Ang 325, ito ngayon, 930. Ang A natin is 930. Ito. Times, ito ngayon, 5-story, 5 floors, is equals to 325 fixtures unit. So, 325, 325, 325. So, ang pinakamataas natin dito sa lower stock is 200 fixtures unit. Pasok lahat yan. Okay yan. So, total is 370 plus 1625. Ito, 1625 is 1955 at least the capacity of the stock. So, the stock load limit is 2,000. Okay. So, okay itong okay. Yung kanina, ang loading stock natin, this National Bureau of Standards. Ang D4 natin, ito table A8. Ang D4 natin is 90. Apat na branches. Yung sizing nito, kung 4 horizontal branch yan, 5 horizontal branch, 6, 8, 10, 12, 15. Ang D4 hanggang 6 horizontal branch. Pero nag-limit na siya sa 80 na lang. Sa 5 horizontal branch, nakapag-limit siya sa 84. 4 horizontal branch, nakapag-limit siya sa 90. 3 horizontal branch, nakapag-limit siya sa 100. So, ang A natin, itong lahat ng mga A na yan, that is the horizontal branch. Ang B niyan is the capacity of that horizontal branch to the stock. So, 3 times 100 is 300. 4 times 90 is equals to 360. 5 times 84 is 420. 6 times, hindi 4 natin, 80 is 480. Hanggang 6 story ito. Hanggang 6 story. Ang size natin, ito ang size natin, hanggang 10 story ang size natin. Ito. Hanggang 10 story, 10 horizontal branch. So, ang deduce natin, hanggang ito, 15 story. Ang ibig sabihin nito, makakuha ka ng branch intervals natin, hindi lang 5. Ang pinaproject ng International Plumbing Code, 5 lang. Lahat sila 5 lang. Nililimit nila itong drain fixtures unit na 1 or 2 branch intervals na capacity. Ang in na ito, sa table receiver. Ito ang load limit ng stock. Ito. So, 530, 14, 29, itong load limit. So, ibig sabihin yan, hanggang dito ang load natin. Ito from the formula, Q, yung formula ng stock capacity. So, ito ngayon, itong table na ito is from Washington, D.C., November 25, 1960. So, hindi ito, kundi dapat sinusundan na lang nila dahil batas na ito ng Amerika eh. Ang IPC dapat sinundan na lang nila ito dahil batas ng Amerika. So, ano na lang gagawin natin dito? Okay. What is our verdict? 250 fixtures unit first stock by using 5 inches pipe, okay, but pipe is not available. Resolve to 6. To a second fixtures unit, to a second stock by using 6 inches diameter, okay. So, puro 6 inches lahat diameter ng stock natin sa example natin kanina. Okay. How to determine the multiple branch interval? As we interpret table 6.3 and table A7. So, yung kanina, sinasabi ko, ito ang formula na kailangan natin. So these are the reference na mag-compute tayo ng horizontal branch natin for this formula. Ang in natin dito, yung table is 7. At saka yung table A8 as a reference. So ngayon, ito na ngayon ang B natin, that is the fixtures unit capacity of the stock. And the horizontal branch capacity for each branch, ito ang formula, i-compute pa. Okay? So, what next? Okay. What is the limit of flow of the horizontal drain for end stock installed for 3 branches? 1, 2, 3. So, limit of flow is 300. Ganito parang may formula tayo. Ang in natin dito is 240. Yung kanina sa table A7. Ayan. Okay. Horizontal drain, limit to soil stock. Okay, the same formula. So this is 90, 90, 90, 90. So 5 branches, 4 inch diameter stock installed for 5 branches. Nagiging 84 na lang ito. Ito, the 4 inches pa rin ito, 84 nito. Hindi ito nililimit sa 90. Kundi, kinukumpute talaga how much is the value of the branch to enter, permissible branch to enter into the stock. Ito ang value na yan. Ito ang value na yan. So kung ilang story yan, 1/2 times number of stories, plus 1/4. Ang in yan is a permissible stock capacity, so 40. Iyon ang 84 na yan. Ito, 84, 84, 84, 84, 84, times 1, 2, 3, 4, 5, 420. So, stock capacity ng D4 is 500. Okay pa rin. Okay. Example, another example, 6 inches. Ang stock capacity is 350. Load limit is 2,900, 1,400 lang. So, gawin natin ng table, 6 inches. Fixtures unit, 3 story, 835. 4 story, 350, 5 story, 325, 6 story, 310, 8 story, 290, 10 story, 280 na lang, fixtures unit. Load limit stock is 2,900. So ito ngayon, ang load limit, itong load limit ng stock capacity 2,800. But the real load limit is 2,900. So dito sa based on this horizontal branches, ito ang kung 10 siya, 2,800. 280 times 10 is equals to 2,800. Okay. Identifying branch interval on drainage stock is critical to protect against overloading, increased venting problems associated with turbulent flow from the branch discharge. So, turbulent ang lalabas. Bakit? Bagsak ka turbulent. Yung kitchen sink natin, na-obserbahan nyo ba pag pinuha yung drain, ang drain plant, o kung pinaplas mo na ganyan, na-obserbahan nyo ba it's whirling? It's whirling. Bakit whirling? Parang whirlpool. Ganun ang sistema. That is a phenomenon. So, ang lalabas nun is the turbulent flow. Siya nagbibigay ng turbulent, siya nagbibigay ng centrifugal force ng system. So, the principles why it should limit the horizontal branch flow, okay, ganito yan. If this is the stock, yung mga tulo lang, bagsak-bagsak na tawag ng slugs, and at the bottom, it will form as a diaphragm, being pushed up by an atmospheric pressure. Pero pag may discharges na ng ganyan, kagaya ng sinasabi ko sa inyo, yung kitchen sink, tinanggalan mo ng plug, dinidrain mo yung kitchen sink mo. Makikita mo ngayon air funnel vortex, umiikot yan, di ba? Umiikot yan. Whirlwind. So, ang whirlwind na yan, it will form an annular. Ito. Ha? It will form an annular. Ito ang hangin na yan. Ito ang turbulence. Kukuha yan ng draft. Turbulent draft. Galing din sa itaas. Yan, nag-ano siya. Turbulent yan. It will form an annular. So ito ngayon, ang ganito mangyayari. Itong annular na ito, kung dito si taas na yan, pinupush niya ito. Pag ito hindi nag-overload ito, nagbabacklock. No? So, i-ano natin ang presentation nito. Kukuha tayo ng finite mass na ito at saka bigyan natin analysis. Kasi hindi lang ito ordinary mathematics. May mga mathematics na differential equation na introduce dito si Dr. Hunter. So, masasabi ko, it's no longer an art. It's no longer an art, but we hire hydraulics. So, ganito yan ang vortex na form na ito. Ano ito? Tingnan natin kung ano sa finite mass na ito. Ang maliit na mass. Itong maliit na mass na tinanggal natin dyan sa thickness of the sheet of pipe water. Okay. Itong center line ng pipe, ng shaft natin o slack natin, ang air core umiikot yan. Pag umiikot yung air core na yan, kasama din ito, iikot din siya yung tubig na yan, iikot din yan. Kasama din si vortex na yan. Di ba yung tubig na dinidrain mo sa kitchen, sa sink, kasama yung tubig nun, umiikot. Umiikot din ito. Ito, tinatawag nila a diagram for evaluating centrifugal force acting on an elementary mass of water moving in a circular path. Ito, umiikot ito. Umiikot yan. Ang ikot niyan, tawag nito ang pwersa na pumapasok dito, tawag na sa centrifugal force. Centrifugal force, which is equal to mv squared over r. Where r is equal to the radius of pipe, m is equal to the mass, which is W over g, n is revolution per minute, the velocity, tangential velocity of omega c is equal to 2 pi rn. Umiikot siya, umiikot. Kaya, itong pag-ikot niya, at saka pagbagsak nito, dahil may weight siya, nagbagsak siya dito, may friction ito sa wall ng pipe. Itong wall ng pipe, ang tubig dito, bagsak dito, ikot ng tubig na yan. Ito ang pumipigil ngayon na maging constant ang velocity downward, which is equal to tawag nila na terminal velocity. Even 100 story, the same velocity to 8 story. Sabi ni Dr. Alfred Stern, parehas lang. Kaya sabi nila, baka pagbagsak doon sa ilalim, water hammer, sobra. Hindi pala. Hindi mangyayari yun. Ito ngayon ang analysis na ito, masasabi ko sa inyo. Hindi lang analysis na makikita natin na ganun-ganun na lang. To analyze nila ito, internally, analyze nila maigi ito pala ang lumalabas. So, this is mathematics. Okay. Pagpasok nito, ang dapat nito may angle. May angle ang flow. Ang dapat nito para itong annular na ito hindi makaka-distort yan. Hindi pagbabackflow. Hindi mawawala ang trap cell na yan. So, ang terminal end, approximately mga 15 bagsak, the same with terminal velocity. So, ang kailangan nito, para hindi umakyat itong backflow natin ng tubig, to a certain edge, kailangan natin ito, ang mas maganda, i-half-filled ito. Para, pumigil man ng kunti yan, mag-rise ang tubig yan, well, naman na hangin naman ito sa itaas na yan. So, when long-term TYs are used for the connection of the branch to the stack, the discharge has a greater vertical velocity. Long-term TY, ganun. the greater velocity component as it enters the stock, and the back pressure are appreciably this maliit lang for the same stock in branch. So, ang relasyon, hindi masyadong malaki yung backflow. Hindi madidisturb yung stock natin, ang pneumatic ng stock natin. Ganito yan. Kung Y ang gagamitin natin, long-term T, Y, at saka kung ang gamit natin is kalahati lang, pumapasok ito dito kasama. Kasama siya. So, may pumipigil niya yung pressure na yan dahil sa umiikot ito, may centrifugal force. Pero, kung mayroon mga pumipigil at saka pumasok na ito, itong space nito, na hangin na ito, hindi mag-create ng back pressure. Dahil aakyat lang siya dyan, hindi siya mag-create hanggang, at saka malaki ang velocity, papasok niya dito. Dahil ito naka-incline, hindi kagaya ng naka-ganon lang. Naka-incline na ito. So, may 45 degrees, kasi Y 45 degrees. So, ganito, long-term T, Y ang kailangan mo dyan. So, this is the definition sketch showing symbols used in the analysis of mutual interference of flows at stock branch junction. So, this is the stock, this is the branch. Ito mga analysis ang kailangan natin. Okay. Anong height ang D4 meron tayo kung gamitin natin stock? Ang size ng height. Ang D8, ang D10, D12. Anong height meron tayo? Okay. Sa National Bureau of Standards, if this is the diameter of the solid stock, kung D4 yan, gagamitin ng D4. At saka yung D4 mismo, ang gagawin mong bench stock. Tingnan mo ito yung intersection ito. 300 feet. Kung hanggang 5 story ka lang, ito pala 300 feet. Paano ngayon yan? So, 300 feet. Nagsinasabi dito, kung resize ka, kung gagamitan mo ang bench stock na D4, ipares mo sa kanya, 364 feet. So, ibig sabihin, 36 story ito. Kung gamitan mo the size ng the size mismo, 51 story. Hindi yung nakalimit ka sa ilang story lang. Okay, like for example, this one. Ang 6 inches natin. Kung 10 feet, ang 6 inches natin, gagamitin natin sa 6 inches. Ang stock capacity nito is 280 fixtures unit. Okay lang kung 10 floor ka. Kung 6 inches, ito gagamitin mo ito sa 25 floor. Pwede ba? Ma-reduce din itong fixtures unit and discharge yan. Ang fixtures unit niyan loading is 2,900 fixtures unit. So ito, ang capacity niya sa 10 horizontal branch is 2,800 to 80 times 10 equals 2,800. Ito ang capacity ng 6 inches. Pero ang capacity ng horizontal dapat 280 lang. Okay. Ito ay galing sa computation natin dito, 280. Ngayon, okay. Itong figure na ito, what must be the horizontal branch for every floor if the solid stock is 6 inches in diameter? 6 inches stock has 280 fixtures unit per floor for 10 floors. If we apply the stock size of 6 inches for 25 floors, ito hanggang 25 floors, the discharge of 2,800 branch divided by 25 is 102. So, ibig sabihin yan, itong mga branches na ito, makapag-discharge na lang ng 112. Pero inabot siya ng 25 story. So, yun ang kailangan natin, So, is the velocity brakes required in the solid stock? Yes. Building more than 3 story above to impede the velocity of the waste. at this velocity break, the stack shall be offset by 45-degree break. A left bend or one-half the size of the sewing stack shall be installed at the top of the second 45 degrees break and shall be connected to the nearest beam stack. Okay. So, velocity break, ito ngayon ang detail ng isang velocity break. So, dalawang 45 degrees, nakakonect ito sa beam stack. Ganito yan. So, hanggang dito na lang tayo. At least, siguro may malaman din kayo na kailangan natin na pag-aralan natin na iba ang recognition internationally. Kung ang pinagmulan ng pinag-aralan natin ay yun na ang planning code natin, kulang sa data tayo. So, anong kailangan natin dyan? So, ito, maski itong international plumbing code, dinadivert nila. Yung iba, hindi na tama ang yung values. Pero kung ilagay mo ito sa itong national code na approve ng Washington DC, ito ang tama. Ito ang tamang paraan sa pag-compute at sa pag-design ng high-rise tall building. So, happy is the man that findeth wisdom and the man that getteth understanding. So, thank you and God bless. So, sana may nalalaman tayo sa sunod. At least siguro, ang iba dito, ma-incorporate natin sa revised national planning.